Welcome to your notes on evaluating expressions. We're going to talk about algebraic expressions. Algebraic expressions are mathematical phrases that contain numbers, variables, coefficients, operations, and exponents. We have an example of an algebraic expression: 3x cubed minus 4x squared plus 5x minus 8. The terms, there are four terms in this expression, and our terms are always going to be separated by an addition sign or subtraction sign. So there's 1, 2, 3, 4 terms. We also have coefficients. The coefficients are going to be the numbers in front of the variables. We have 3 coefficients: 3, -4, notice the negative sign, 5, and we are not going to call -8 a coefficient because it's not in front of any variables. The -8 gets its own name, and that name is constant. It's constant, it's not changing, it's always going to be a -8. It's the number without any variables. And finally, we often find exponents. Our exponents are going to be the exponents of the variables, and they're the powers we're raising the variables to. In this case, the 3 and 2 are exponents. Go ahead and take a moment to try this on your own. Let's see if you can figure out the terms, coefficients, and constants from our expression. I'm hoping for the terms you found 2x squared, -16x, and 32. The coefficients, remember the coefficients are the numbers in front of the variables, are 2 and -16, and we have one constant, positive 32. Now that we've talked about mathematical expressions, let's take a numeric expression, all numbers, and let's see if we can simplify it using PEMDAS, also known as the order of operations. Please excuse my dear Aunt Sally, or please excuse my dumbass sister. P is going to stand for parentheses. The parentheses means we're going to do everything inside the parentheses first. So in our example, we're going to do 1 minus 6 times. We're going to do the stuff inside the parentheses. It's going to give us a 3 plus 5 squared. After the parentheses come exponents. Remember, exponents tell us we're multiplying a number by itself so many times. We have an exponent, this 2, so we're going to take care of that exponent. We're going to write everything else down. 1 minus 6 times 3. We're going to do our exponent, 5 squared. 5 times 5, 25. Now the next part is a little more confusing. The M and the D really are on the same level. So if we see multiplication or division, whichever one we read first from left to right, we're going to do first. So as we're looking through this, we do have some multiplication between the 6 and the 3. I don't see any division, so we're not going to do any division. So we're going to do multiply, divide, and we're going to do those in order. So I have a 1 minus a 6 times 3 is an 18 plus a 25. Finally, using the same kind of idea, we're going to do addition or subtraction. If there's any addition, subtraction, we're going to do whichever one comes first from left to right. So we're going to do add, subtract. Clearly these can be subtracted, and then that resulting number will be added. So 1 minus 18 is going to be -17. And to the -17, we're going to add 25. 5. So -17 plus 25, I believe that will be a +8. Next, we're going to actually evaluate our expressions. In order to evaluate our expressions, we're going to need to use PEMDAS. We are also going to need to understand where to plug things in. When we're evaluating an expression, this says for x equals 2. So instead of having an x over here, I want to replace all the x's with the number 2. 2 times 4 times 2 minus 10 to the third power. Following PEMDAS, we're going to do the stuff inside the parentheses first. So we have 2 times 4 times 2 would become before we subtract or add. So 8 minus 10 cubed. Still have stuff inside of the parentheses, so we're going to go ahead and do that. So we're going to do 8 minus 10. It's going to be negative 2 to the third power. Negative 2 to the third power means negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4 times negative 2 is negative 8. So we have 2 times negative 8, resulting in an answer of 16. Negative 16, excuse me. Now, if we're doing with this negative number, it's pretty much the exact same thing. We just have to be careful of that negative sign. Plugging in the negative 3, anywhere we see an x, anywhere and everywhere, right? Stuff inside the parentheses first. Going to go ahead and add those two terms. Negative 12 plus 10 is going to be negative 2. Negative 2 cubed is going to be negative 8 again. So we have negative 3 times negative 8. And negative 3 times negative 8 is now going to be a positive 24. Let's do this in the form of a word problem. Sheila is participating in a multi-day bike trip. On the first day, she rode 100 miles in 8 hours. Use the expression d over t, where d is the distance traveled and t is the time, to find her average rate of travel. Include units when evaluating this expression. So we have two important things from our problem here. First of all, 100 miles, that's going to be a distance. So for the distance, I'm going to put 100 miles. Okay? The second important thing that we're told in our problem is in 8 hours. That's time. So for the hours, I'm going to put 8 hours. And then I'm going to go ahead and simplify my expression. We have 100 divided by 8, which I believe is going to be 12 and a half. And these units are just kind of going to go along for a ride. We're going to read this as miles per hour. So Sheila was riding 12 and a half miles for every 1 hour. Now we need to remember this because it's going to be part of our next problem. If Sheila continues riding it at her average rate for the first day, then the expression 100 plus 12.5t gives the total distance on the second day. Explain what each term represents. So we have the term 100 plus the term 12.5t. And I kind of feel like each part of this is going to have its own special meaning. Okay? The 100, if you remember from the previous problem, is how far Sheila rode on day 1. Right? She rode 100 miles, so it was distance on day 1. She's already done that. We're not going to be able to take away the 100 miles she's already ridden, crazy. And we're going to add whatever she rides the second day to that 100. Okay? Now let's look at the second term. It has two parts, a coefficient of 12.5 and t. Well, we've seen the 12.5 before, just like we saw the 100 before. The 12.5 represents her average speed, how fast she was riding per hour. And it turns out the t is pretty easy to figure out as well. the t is how many hours or time? So if we know this, let's evaluate the expression for t equals 7, including units. So we want to know if Sheila rode for 8 hours on day 1 and went 100 miles, and 7 hours on day 2, how many total miles does she go for? Well, we can't take away the 100 miles she's already ridden. Crazy. And we know she's riding 12.5 miles an hour for 7 hours. I might add, that's also crazy. We can figure out how far she's gone. Just going to evaluate our expression. 12.5 times 7 is going to be 87.5. So we have a distance of 100 plus the 87.5 we get from riding 7 hours at 12.5 miles an hour. Notice, I'm following the order of operations. I'm doing multiplying before I add, and then I'm going to add my final two terms and get 187.5, and it's important that we include miles. Thank you for watching today's video. Look forward to seeing you in class tomorrow. Have a good night.